Next, we'll start the next topic, that is a Bayesian learning method. So what is the meaning for the Bayesian learning method? So these Bayesian learning, it provides a probabilistic approach for the inference, and it is completely based on the assumptions that quantities of interested probability of distribution with together of the observed data. So here, Bayesian learning methods are relevant to study the machine learning for two different reasons. Okay, so the first reason is Bayesian learning algorithms that calculate the explicit probabilities for hypotheses such as Naive-Bayes classifier, or among the most practical approaches of the learning problem. So that is one of the reason that why the Bayesian learnings are relevant or it is required to study the machine learning. And the second reason is that they provide the useful perspective for understanding the many learning algorithm that do not explicitly manipulate the probability. So that is one of the second reason that why we are going to require the Bayesian learning method. And next, coming to the features of the Bayesian learning method. So here, each data can incrementally decreases or increases the probability. Whatever the data which is given by the user, either it can be a increases or it can be a decreases by the data. According to this, it will going to provide the more flexible approaches to learn the algorithm. So here, prior knowledge can be combined with the observed data to determine the final probability of the hypothesis. Okay, so in Bayesian learning, prior knowledge is provided by the prior probability for the candidate and as well as the probability distribution. So here, this Bayesian methods will going to accommodate the many hypotheses that can be used in terms of the prediction algorithm. So that is why the different algorithm is the Bayesian learning will going to prefer the much imitated estimated probability of data. Practical difficulty in applying the Bayesian method. So in some of the conditions, it is difficulty to apply the practical method for the Bayesian method. Why it is a difficulty? We'll see that there will be two approaches for that facing the difficulty. That one practical difficulty in applying this method is that they require the initial knowledge of many probabilities. So that is the one thing. And again, a second practical difficulty is that significant computational cost which is required to determine the base optimal hypothesis in the general case. Okay, so these are the two different difficulties that we're going to face in the Bayesian methods. And next we'll see with the Bayes theorem. It's an important question that can be asked in the many of the exams and as well as the testers. So that is what is the P of H? Before we are going to start with the Bayesian theorem, we'll see that what is the P of H, P of D, P of D over H, and P of H over D. That is P of H. It is nothing but the probability of H hypothesis, which reflects any background knowledge about the chances that H is correct. And probability of D is the prior probability of D, and the probability of D over H is the probability of observing the D given the word, and again the probability of H over D is the posterior probability. So this is what the Bayes theorem, that is probability of H over D, which is equals to the probability of D over H into probability of H divided by the probability of D. So here always we're going to call this probability of H over D is known as a posterior probability, and probability of H we are going to call it as a prior probability, and together this P of D over H and P of D we are going to call it as a posterior probability with respect to the prior and the posterior togetherness. Always this P of H over D, it can increases with the P of H with the probability of D over H according to the Bayes theorem. Next, probability of H over D, it decreases as the probability of D increases, because the more portable it is that the D will be observed independent of the H with respect to the evidence which will be supported. So in this, we'll see that this is an data with over the probability of H over D, and this is the likelihood reality probability. So this will going to calculate the Bayes theorem value. And one example, real-time example they have given to calculate the Bayes theorem. That is, a patient will going to take say lab test and the results come back positive. The test returns the correct positive result only in 98% of the cases in which the disease is actually present, and correct negative result only in the 97% of the cases in which the disease is not present. Okay, so further 0.008 of the entire population have this cancer. So this is a question they have given and we need to calculate the answer. So we're going to calculate this by using the what's the probability of cancer they have given and what is the probability of positive the result we are getting as a cancer and the probability of result as a negative we're going to get as a cancer. So here the probability of positiveness is almost 0.98 and negative is a 0.2. A negation of this positive is 0.03 and negation of the negative is 0.97. And we're going to calculate the hypothesis of maximum posterior, that is a negation of the value. We're going to get it as a 0.07 as a value that we have got it. So next is the maximum posterior hypothesis. So this maximum posterior hypothesis can be provided by the formula, that is argument maximum of probability of H over T with respect to the H over H belongs to hypothesis. So in place of this Bayes theorem, we can replace this probability of H over D. In place of that, we have written probability of D over H into probability of H divided by probability of D. So as this value is a negligible value, so we are removing this value only. This is a maximum height. The maximum hypothesis we got, that is as a hypothesis. So next is a maximum likelihood. So that we'll discuss in the next session.